Hello children, today I'll start a new chapter, Rational and Irrational Numbers. I think you have already gone through rational number as you have gone through sets. There you have learned natural numbers, whole numbers, integers, rational numbers, that is real number also. Okay. Irrational numbers may not be known to you. So I am discussing about the rational number. The number which can be expressed in the form P by Q is known as rational number. What are P? P are Q are integers belonging to Z. With the condition Q not equals to 0, you see Q in the denominator. What did I say? The Q integers. So integers mean positive, negative, 0. But in mathematics, division by 0 is not allowed. So Q must not equals to 0. First condition. The second condition is P and Q are prime to each other. P and Q are prime to each other. What does it mean by the word prime to each other? See, for two numbers to be prime to each other, it is not necessary that they are all prime. They may be prime, may not be prime also. What is the condition required? Except one, they don't have any other common factors. Okay. Like 2 and 3, these two are prime. If they are prime, then no question, they will be prime to each other. But two non-prime numbers or one prime, another non-prime also could be prime to each other. Now see, two numbers I have taken here, 15 and 16. No one is prime. No one. What are the factors of 15? If I find, I'll get 3, 5 and all the factors if I write 1, 3, 5, 15. Okay. These four factors are here. And if I find the factors of 16, then 1, 2, 4, 8, 16. Okay, you see, except 1, they don't have any common factor. That it has 3, 5, 15. It has 2, 4, 8, 16. So, 15 and 16, though they are non-prime, but they are prime to each other. Hope you understood this thing. Now, terminating decimal. What are terminating decimal? The decimals are the fraction which can be expressed in the form with decimal number after converting to fraction. If we can express this in this form, P by 2 to the power n into 5 to the power n, where P belongs to Z, that is P is prime. P is an integer. And Mn are whole numbers. Mn belonging to W. Okay. Then we can say that it is a terminating decimal. Otherwise, if the decimal or fraction cannot be expressed in the form P by 2 to the power n into 5 to the power n, then they will be non-terminating recurring decimal. Okay. Hope you know what are recurring decimals. That is, the division never comes to an end. If you divide 10 by 10 with 3, 20 by 3 like this way, if you divide, they will not come to an end. They will be recurring. So, in every case, it is not possible to dividing it and checking it whether they are terminating or not. So, this is the form. Okay. So, let's check one sum. From your book, question number 1. Which of the following, some fractions are given, which of the following will change into a terminating decimal? What are the fractions given? 13 by 20, 125, 2 by 9, 23 by 60, 7 by 250. Now, 13 by 125. Let us factorize it. Okay, what I am getting? 5 into 5 into 5. That is 5 to the power 3. And I am writing 2 to the power 0 as 2 to the power 0 means 1. So this given fraction is converted to p by 2 to the power n into 5 to the power n form, where p is an integer and mn are whole numbers. So it is terminating decimal. Now second one, 2 by 9, that is 2 by 3 square. This is not of the form p by 2 to the power n into 5 to the power n. So it is a non-terminating decimal. Next, 23 by 60. After factorizing, what did I get? 2 square into 3 into 5. This is also non-terminating, as this is also is not in the form p by 2 to the power n into 5 to the power n, because 1 3 is there. If no other factor other than these two are here, it cannot be expressed in the form p by is not taking the form of this, so it is also non-terminating decimal. The last one, you see, 7 by 250. After factorizing, what I am getting? 2 to the power 1 into 5 to the power 3. So it is of the form, so it is also terminating. So what did we get? 13 by 125 and 7 by 250. These two are terminating decimal. Okay. Next, I will teach you recurring decimal. What are recurring decimal? Recurring decimal, I think the division never come to an end. In that case, what we are doing, which number are repeatedly coming, we put a symbol dot or bar on the top of them and expressing by this way the recurring part. Okay, so how to change a recurring decimal to a fraction? What to do? What is the number given? We'll copy that. Then we'll check. We'll write all the digits in order, without decimal or recurring decimal, without using this symbol. We will just write the digits in the number in order, minus all the non-recurring digits also in order, leaving the decimal symbol. All the digits I will write. If there is any decimal symbol in between them, we'll ignore it. Only the recurring part will leave. Okay. Then by, divided by, we'll write the number of nines. How many digits under recurring decimal? That many 9 I'll write. Okay. Number of nines equals to the number of digits under recurring decimal. Then with that 9, if required, I'll write some zeros. How many zero I'll write? That number depends on the non-recurring decimal part. The digits are after a decimal but not under recurring decimal. That number of 0 will count and will put. Now I'll show how to find it, then it will be clear to you. 2a. What is given? 4.125. These 2 and 5 under recurring decimal. Okay. It may be given like this bar also. Okay. 2 and 5 are under recurring. So one bar may be given or 2 dot may be given. Okay. So what did I say? I'll write first all the digits in the number, leaving decimal and recurring decimal. So leaving all this thing, I am writing 4125. I have written that. Then all the digits in the non-recurring part except decimal. So these 2 and 5 are under recurring. So other than these two, what are the digits? These are non-recurring. So that is 4.1. But whenever I write, I leave this decimal. Okay, then 4 and 1. 4 and 1. Then I'll count how many digits under recurring decimal. 2 and 5, that is 2 digits. That number of 9 I have written, you see. 9 and 9. Then after decimal, how many digits are there? Only 1 digit. So 1 0 I have written. Now subtracting. What to do? The question is convert it to a rational number. Okay. So if there is any common factor, it will not be a rational number. Okay. So 2042, 495. Cancelling the common factor 2 from both numerator and denominator, we are getting 2042 by 495. One more time I am showing from this question number 2D, 0.4672. See, if one digit under recurring, so 1 dot. If 2 digit under recurring, so 2 dot on the top. You see, 2 dot in the previous sum. But if 3 or more numbers under recurring part, then at first and the last 2 dot is given, that is in between all these are under recurring decimal, that is 6, 7, 2, all this. If it is given bar, then the total, okay, that is 6, 7, 2, all these are under recurring decimal. Now, what is the formula? I am writing all the digits in order except the recurring and decimal and recurring decimal. So, what is coming? 4672 minus non-recurring part except this 672, what are there? 0.4, but I have to write except point, okay, other than the point decimal, that is minus 4. Then how many digits under recurring decimal? 6, 7, 2, 3. So 3, 9 I have written. Then after decimal, how many digits not under recurring decimal? Only 1. This 4 not under recurring decimal. So 1, 0. Then I have subtracted, calculated, that is cancelling the common factors, first by 2, then by 3. I got finally 778 by 1665. Okay, see the calculation shown here. Next sum, question number 3. Find the largest and smallest rational numbers from the following. The numbers are given, positive, negative, all types are given. 4 by 7, minus 4 by 7, 5 by 9, minus 7 by 15. So I have to find the largest and smallest. If there is only one negative, then we can, without calculating, I can say that that is the smallest. But there are 2 negative, so we have to calculate. So how to do this? I am taking first, I am making the denominator same that you have learnt in your previous classes also. So what I have done? I have taken the LCM of 7, 7, 9, 15. I have done here. And what is coming the LCM? 315. So I am making all the denominators 315. So first 4 by 7 divided by 7, what is coming? 45. So I am multiplying both numerator and denominator by 45. So what is coming? 180 by 315. Next one, except the negative sign, all these things same. So it is also coming minus 180 by 315. Then 5 by 9, this is coming 175 by 315. Minus 7 by 15, it is coming minus 147 by 315. Now, which one will be the smallest? Which one will be the smallest? We have to find out. See, all the denominators same. So, to find the smallest, we have to check only the negative signs, negative numbers. That is minus 180 and minus 147. So, this one will be the smallest. Okay, negative. So, it is coming from the minus 4 by 7. Actually, what is given in the question, that one we have to find. What we have converted, what do you get after calculation, that is not to our look out. Okay, that is to find out doing this, we require this only. Then whenever we are writing the answer, we have to take the number given in the question. Minus 4 by 7 is the smallest number. And the greatest one must be 180. 175 and 180. Denominator same. So this is the greatest. So the largest number is 4 by 7. So minus 4 by 7 is the smallest number and plus 4 by 7 is the largest number.